Hello and welcome to another LeetCode solutions video. This is problem number 15, threesome. For this problem, given an integer array nums, return all of the triplets, nums of I, nums of j, and nums of k, such that I does not equal j, I does not equal k, and j does not equal k, and nums of I plus nums of j plus nums of k equals 0. Notice that the solution set must not contain duplicate triplets. For example 1, we're given an input nums array of -1, 0, 1, 2, -1, and -4. And for this, our output will be -1, -1, 2, and -1, 0, 1. This is because nums of 0 plus nums of 1 plus nums of 2 is equal to -1, 0 plus 1, which equals 0. Also, nums of 1 plus nums of 2 plus nums of 4 is equal to 0 plus 1 plus -1, which equals 0, and nums of 0 plus nums of 3 plus nums of 4 is -1 plus 2 plus -1, which equals 0. Since the first and the second are duplicates, we can drop one, and the distinct triplets are -1, 0, 1, and -1, -1, 2. For example 2, we're given nums equal to 0, 1, 1, and the output is nothing, and this is because the only possible triplet does not sum up to 0. And for example 3, we're given nums equals 0, 0, 0, and the output is 0, 0, 0, because the only possible triplet sums up to 0. Let's go through an example. For this example, we're given the nums array of 1, -1, 0, 0, 2, 4, and -2. The first thing we want to do to make this problem a bit easier is to sort our array. With it sorted, our new array is -2, -1, 0, 0, 1, 2, 4. This will make it a lot easier to find duplicate triplets and ignore them, as well as make it faster to find 3 numbers that add up to 0. Next, we're going to want to loop through our sorted array. When looping, we'll want to keep track of our current index in the sorted array, as well as 2 pointers. One pointer pointing to the next index in the array, and the other pointer pointing to the last index in the array. To determine if this is a triplet that adds up to 0, we want to add up our 3 pointer values. In this case, the sum will be equal to 1, so we don't have a triplet. And since our sum value is greater than 0, we want to move our right pointer to the left to see if there's a smaller value we can use to get a sum of 0. So our right pointer is now pointing to 2, and our sum is now -2 plus -1 plus 2, which is equal to -1. This does not equal 0, so this is not a valid triplet. And since -1 is less than 0, we want to move up our left pointer now. So now our 3 values is -2, 0, and 2. So our sum will be equal to 0. So this is a valid triplet. And we'll add it to our output. And since this is a valid triplet, we can move our left pointer to the right until we hit a new unique value. And we can do the same with our right pointer as well. This will cause our 2 pointers to overlap on 1, so we can move on to our next index. So now our new triplet is -1, 0, and 4, which adds up to 3, which is not a valid triplet. And since this value is greater than 0, we'll move our right pointer inwards. Now our new triplet is -1, 0, and 2, and this equals 1. And our sum is still greater than 0, so we'll move our right pointer in again. Now our new triplet is -1, 0, and 1, which adds up to 0. So this is another valid triplet. We can add this to our output. And we're going to end up moving our left and right pointer, and they'll overlap again, so we'll just move our index up to the next value. Our new triplet is 0, 0, 2. Adding that up, we get 2. This is not a valid triplet. And since our sum is greater than 0, we'll move our right pointer in again. Now our triplet is 0, 0, and 1. Adding that up, it's 1, which is not 0, so it's an invalid triplet. And since the next move of our right pointer will cause an overlap with the left pointer, we're going to move to the next index. Our new triplet is 0, 1, 4. Adding that up, we get 5, which is not equal to 0, so it's an invalid triplet. And since 5 is greater than 0, we're going to move our right pointer again. Our new triplet is 0, 1, and 2. Adding that up, it's 3. It does not equal 0, so invalid triplet. Our pointers are about to overlap again, so we'll move to the next index. And finally, our triplet is 1, 2, 4. Adding that up, we get 7, which is not equal to 0. And now we've gone through all possible triplets. So our output for this problem would be -2, 0, 2, and -1, 0, 1. Let's jump into the code. First thing we're going to want to do is define our result array. And we'll want to sort our input array. Now we'll want to loop through our sorted array until we are 2 from the end of our array, And this is because once we get to that point, we will no longer have enough numbers for triplets. And to avoid duplicates, we can add a check at the beginning of our loop to make sure our current index value is not equal to its previous one. If it is equal to the previous value, we'll just continue because it'll be a duplicate triplets. Next, we'll want to define our left and right pointers. Our left pointer will point at the next index in the array, and the right pointer will point at the last index in the array. And now, while our left pointer is still less than our right pointer, we're going to want to check the sum of the triplet as well as move our left and right pointers accordingly. And we'll get the sum by adding our triplet together. If our sum is less than 0, we'll move our left pointer up 1. If our sum is greater than 0, we'll move our right pointer down 1. And if it's equal to 0, we'll add our triplet value to our result. And at this point, to avoid further duplicates, we can move our left pointer to the right until it's no longer equal to its current left value, and we can move our right pointer to the left until it's no longer equal to its current right value. And now at this point, we'll want to increment our left pointer and decrement our right pointer. That's it for the looping, so we'll just return our result at this point. And that's it for this solution, so let's run this. I made one syntax error. I accidentally wrote total here instead of sum, so just change this to sum and run it again. All test cases passed, so let's submit this. Our solution was accepted, so that's it for this problem. If you like this video and want to see more content like this, make sure to check out my channel. Thanks for watching.